All right, guys. Today we're going to do the inverse of a 3 by 3 matrix. So we're doing inverse of a 3 by 3. There are two ways to do it, and they're both algebra heavy. All right. So pretend I have a matrix here of -2, 5, -4, 0, -3, 5, -5, 5, and 6. Here's the matrix, and I want to find its inverse. Okay. In order to do this, first you need to find its determinant. So first step is find determinant. Okay. So the determinant of this matrix, which we did before, there's two ways. Either we write the first two columns, you use the plus minus, or you can do the expansion of rows or whatever. I'm going to let you know, I already did this determinant. It came out to be a -51. Okay, so the first method of doing the inverse of a 3 by 3 is called by the row and column method. So here we go. I'm going to call this new matrix N. So N. So the first one that you're going to do is I'm going to knock out the first row, first column, and I'm left with these four numbers, the -3, 5, 5, and 6. So I end up with -3, 5, 5, 6. That's the first row, first column. Okay. Now, if I knock out the first row, second column, which is this and this, I'm left with 0, 5, -5, and 6. And then if I knock out the first row, third column, I'm left with 0, -3, -5, and 5. And that's just the first row. Now we're going to do the same thing with the second row. Second row, first column, knock that out. You're left with the 5, -4, 5, 6. Second row, second column, -2, -4, -5, -6. And knock out the third one, you end up with -2, 5. And then -5 and 5. And lastly, now I got to do the third row. Third row, first column, knock that out. You end up with 5, -4, and -3. Let's see, knock this out. -3, -5, -3, 5. Then the second one is -2, -4, and 0 and 5. And the last one, excuse me, -2 and 5, 0 and -3. So this is your matrix, which is it's not the inverse yet, but it's this big matrix. And then what we have to do is we actually have to do this. And this is easy. We did this before. This is -18 minus 25. So, I mean, wait, did I mess up? Oh, shoot. This should have been a -6 right here, guys. Sorry. Because I'm looking at my notes. So this is a -6 right there. Okay. This should have been a -6 over here. Okay. And I am good. Okay. So this would have been 18 minus 25. So this is what you end up with when you do this whole thing. You end up with a -7, a 25, -15, -10, -8, 15, 13, -10, and 6. Okay. So remember we talked about that convention of the plus minus. This has to be done over here because in the next step, that's what it has to become. This is plus minus plus. This is going to be, let me circle this so you know. Then this should be minus, plus, minus, plus, minus, and plus. All right, so this new matrix M is going to become, what you're going to do is you are going to take this main diagonal, the 7, the 8, and the 6. Do you see that main diagonal? So this becomes a negative 7. This becomes a negative 8. This becomes a positive 6. That's my main diagonal. And then we are going to rewrite all of that. So this becomes negative 25 and negative 15. This becomes a positive 10. This becomes a negative 15, a 13, and a positive 10. Remember, this is the main diagonal. Sometimes it's easier if you just highlight that main diagonal, because what we are going to do is we are going to now, to find the inverse, we are going to reflect these numbers along this main diagonal, meaning that these two will swap, these two will swap, these two will swap. So I end up with, here's my main diagonal, and if I swap, then this becomes the 10 over here and the negative 25. Do you see how that swap went? This swap right here, that becomes a 13 and a negative 15. And finally, this swap, this is a 10 and negative 15. Okay, so we should end up with a negative 7, 10, 13, negative 25, negative 8, 10, negative 15. This is after the swap. All we have is one more step. Remember that determinant that we did up here? So to find the inverse, A inverse is 1 over that determinant times this matrix. Okay. And now all we have to do is do our multiplication. So our inverse would be 751, 10, negative 10 over 51, negative 13 over 51, 25 over 51, 8 over 51, negative 10 over 51, 15 over 51, 15 over 51, and negative 6 over 51. This is your inverse matrix right there. Now, I know I didn't reduce, but you can reduce. But just for the sake of time of how to do these, this is how it's done. So first is, let me recap this. Find the determinant. Second, do each row in each column, and then find their answers. Third, make the sign convention, and then this is what the sign would be after you do the sign convention. And then fourth is to flip over this diagonal. And finally, fifth is 1 over the determinant times whatever matrix that you got here. So this is one way of finding the inverse of a 3 by 3. A lot of algebra. Let me show you another way. I'm hoping that this second way is a little bit easier, but you have to be careful of what you're doing. So let me pretend I have this matrix, 3, 4, 5, -4, 6, 3, 1, -4, 3. And I want to find its inverse. All right, no matter what, I still need to find the determinant of this guy. So step 1, determinant of A. Again, I did this and I came up with 200. All right, so the first step that I would like, well, that's the first step to use to find the inverse. The first thing that I need to do when you find the inverse is I want you to rewrite the first two columns. So I'm going to rewrite this without these. So you got 3, -4, 1, 4, 6, -4, 5, 3, 3. Oops, hold on. The zooming went out. Hold on. All right, again, so find the determinant. After you do that, what I wanted you to do is the first thing is to rewrite the first two columns on the right hand. The first two columns, and then rewrite the two rows. All right, so we have, first, I'm gonna rewrite the first two columns. 3, -4, 1, 4, 6, -4. So let me call that part A. Rewrite column 1, column 2. Then what I want you to do is take the first two rows and rewrite them and put them underneath. Let me put this on the right. And then I'm going to rewrite row 1, row 2 on the bottom. So whatever row 1 is, rewrite it. You see it? That's row 1. Here's row 2. And you end up with this guy. Okay. So what we are going to do is that we're going to do somewhat of that row column thing that we did above. So I'm going to highlight the row and the column right there. See that? All right. So here it is. Do you see these first four numbers right there? See that? That's going to be row 1, column 1. 18 minus a -12. So 18 plus 12, that's going to be 30. And every time that you go down, you see these 4? Then I'm going to do these 4 right here. Then I'm going to do these 4 right there. But going down is like going across. So going down is going across. And why that reason is, remember that we did that reflection? So these numbers will actually be up there when we do this. So this is just because of that reflection that we had. All right, so, and we don't have to worry about the signs. So if I want to do the inverse, it's 1 over the 200. And now I'm going to do these 4 right here. I said that was 30. Then this one right here, the -4, 3, 4, 5, you see that's -20 minus 12, that's a -32. It would have been down here, but because I have to reflect it, it becomes up there. And these 4 right here, 12 minus 30 is -18. And now I'm going to do the same thing with The next, see these 4 right here in the middle? 3, -4, 3, 1. See those? So if I do that, 3 minus a -12, that's a 15. Then these 4 right here, 9 minus 5 is 4. Then these 4 right there, -20 minus 9 is -29. And then finally, I'm going to do these 4 right here, then these 4, then those 4. And you end up with 10, 16, and 34. And all we have to do now is, multiply 1/200th times all of that. And then reduce. But I can keep it like that if I want to, but it's your preference. So these are the 2 ways that I have for finding the inverse of a 3 by 3. I think this is a little bit easier. All you have to do is rewrite the first 2 columns, then rewrite the first 2 rows, and then you're going to do every 4 that you see is going to go across because of the reflection. Okay, so this is how you find the inverse of a 3 by 3. I will send out the homework in a second. Bye, guys.